Alright, so I've been wanting to make AP Chemistry videos for a bit and just like explain some of the base concepts just so that you have a solid understanding of it. So if you ever get confused, you can come look at these YouTube videos and all that kind of stuff. So I've been procrastinating it all summer, but I had to shave, so why not? Now I'm in a school mode. First thing, basic, moles. This deals with Avogadro's number, mole ratio, all that. So Avogadro's number, if you ever need to use it, which you will for like conversions, times 10 to the 23. That's if you need to use it for like conversions, which we will get to conversions in stoichiometry, also known as dimensional analysis. But also, quick note, if you are putting things into your calculator, use the little E button. Just FYI. Okay, so that is what this is. That's the number for moles. But the reason you need to know about moles is because something called mole ratio. So say you have A plus B goes to C. But rarely do we have everything being ones. So say you have 2A plus 3B goes to like 4C because, I don't know, that's how math works now. So yeah, the mole ratio for 2, 3, 4. That's going to come in when we do stoichiometry, which let's go and do that now. So say you want to know how much C you're going to produce if you're given 1 mole of A. So 1 mole of A times, when you're doing stoichiometry, you bring this dude down here. So mole ratio, we have 2 moles of A to 4 moles of C. And then 1 mole of C. And we don't have any grams because I don't know what the grams of C is. So we're just going to convert it to particles, and that's where you can use this. So 6.02 times 10 to the 23 particles. So my main calculator is currently MIA, so you just do 1 times 4 times 6.02, and this is the little E button I meant. That one. That way, if it'll focus, you have an E there instead of the times 10 to the, because it can sometimes get weird. There, and then divide by 2. So with this, with 1 mole of A in this reaction, I would end up with 1.204 times 10 to the 24 particles of C. That's how you use moles and stoichiometry to figure out what's going on in a reaction. So this process right here is called stoichiometry or dimensional analysis, and moles are using these things for the mole ratio. This right here is mole ratio, and this is Avogadro's. That's Avogadro's number, and that's where you use Avogadro's number to make conversions. Now I'm going to pause this, erase it, and talk about limiting reactant, which is fancy stoichiometry. Alright, so now we are going to be going over something called limiting reactant, which is where you have, like in the other reaction where I said, like, we have some A and you get to C, B was completely irrelevant. What would be given in a word problem like that is you have some A, and you have excess B, and you're trying to find C. But in this problem, you are going to be told you have so much A, so much B, how much C do you create? Again, I don't have grams of B and A and C, so I'm just going to go straight to moles, but a lot of times you'll have to convert from grams to moles, because for this thing you have to be in moles. Cool? So we're just going to make it easy and say that we start with 1 mole of each, and you want to make what's called a BCA table. And remember this because later you'll make something very similar. Before, change, after. So before you have 1 mole, 1 mole, and 0 moles. The change is going to be the mole ratio. So it's minus 2x minus 3x and then plus 4x. How do we find out what x is? You divide before by the change. So this x is 1/2 and this x is 1/3. So the smaller x is going to be the limiting reactant because, like, if you do 1 minus 1/2 times 3, that'd be 1 minus 3/2, and that's 1 minus 1.5. You can't do that. You'd have a negative number. You can't have negative matter. That's terrifying. So you have to use the smaller one. So 1 minus that 3 times is 0. 1 minus 1/2, or 1 minus 2 times 1/3 is 2/3. So, wait, what did I do? Since x is 1/3. Then we come over here, and plus 4x, x is 1/3, so plus 4/3, so it's just 4/3 is your after. So how much C do you produce here? You produce 1.33 moles of C, and you can convert that over to particles or to grams if you're given grams. And then it may ask you what's the limiting reactant. The limiting reactant would be B. And what is the what reactant is in excess? It would be an A. How much of the excess element is left over? It'd be 0.33 moles. So that's kind of how a limiting reactant works. And remember, the smaller x is the limiter, and just kind of work it out like that. And the way I do this is because what's actually happening is 1 minus 2x equals 0. So 1 equals 2x. So 1 over 2 equals x. So you can just skip that process and yeah. But that's how limiting reactant works. And I'll go and keep this mildly short, and this is one video. This is the math that is the basics for get in the frame. This is the math that is the basics for pretty much everything you're going to be doing in chemistry. So yeah, make sure you have stoichiometry and BCA tables down.